All right, thanks for sticking with us here. If you watched part one of the video, we talked about the different kinds of solution sets that you can have, the number of solutions. So you have a case where the lines intersect, all right, in which that's going to give you one solution. You have a case where the lines don't touch each other and they're parallel, and therefore that gives you no solution. And you have a case where they lie on top of each other. So we've got three examples here from Alex that we're going to go through together. So it says that you're showing these three examples. For each of these, choose the best description of the solution, and if it has one solution, tell them what it is. So system A, right? Um, Line one is marked. That's this one right here. And then line two is right here. Okay, you can see that they have different slopes. So because they have different slopes, that should tell you right away that they're going to intersect at one point. Okay, so we know that looking at this, it only touches in one spot. All right, so that would be right here. And then the solution is going to be, where does it intersect? Well, it intersects at the point -3, 0. Okay, so we'll go -3, 0. All right, move on to system B. Well, you notice how they have the same line marked with line one and line two. And if you look up here, if I moved this over to the other side and got this in slope intercept form, you would see we have the exact same equation. All right. So when you have the exact same equation, it means that everything that works in one equation works for the other. So it's infinitely many solutions. And then this last one right here, you can see that they have the same slope. They both have a slope of 2, but one has a y-intercept of -3 right there, and then one has a y-intercept of 4. So they have the same slope, meaning, but they don't touch each other, meaning they are parallel. And so when that happens, they have no solution because they don't touch each other. All right, let's try one more. So system A again. Let's see if oh wait, we did this one. I keep forgetting to move on. Thanks for bearing with me, guys, and my technology glitches. All right, system A. So again, without even looking at the picture and looking at these equations, they have the same slope. They both have a slope of -1, but this one has a y-intercept of -3, and this one, because it's not listed, has a y-intercept of 0. So that's like a direct variation equation, right? So that means that same slope, but different y-intercept, they're not going to touch. That means they're parallel. And if they're parallel and they're not going to touch, you have no solution. All right, system B, well, looking at the graph, you can see that, well, they touch in one spot and they only touch once, and they touch at the point -1, 2. And then that would be my one solution. All right, they can't have more than one solution unless one of the lines bent. And if that happened, it wouldn't be a linear equation anymore, because linear equations mean they're lines, straight lines. All right, system C, again, like the other example, it looks like they've got one line lying on top of the other line. And if you look at the equation, if I take this, move -3x, just bear with me here. If I move -3x over here to the other side, it will give me 3x. And then if I divide by 4, everything by 4, I'm going to have a slope of 3/4. So I'm going to have the exact same slope. And the same thing's going to happen with the y-intercept. So if I divide -8 by 4, I get -2. So you have the exact same equation, basically, just written two different ways. So this would be a case where it has infinitely many solutions, because whatever you put in one equation is going to work in the other equation. All right, so I hope this helped you guys. Um, just if you can, it's kind of common sense with this. If they touch each other, in one spot, that means you have one solution. If they never touch each other, there can't be a solution. And if they're touching each other all the time, then there's infinitely many solutions. So that's kind of how that works. Hope this was helpful to you. And then you can watch the last video on application problem.